Trapezoid midsegments. The midsegment of a trapezoid is basically a segment that connects the midpoints of the legs. It's right smack dab in the middle of this trapezoid, okay? And so if you look at the two parallel sides, okay, those are the bases. If you go to the legs, if you identify the midpoint on each leg and connect it with a segment, it gives us this thing called a midsegment. And that thing is important for a couple reasons. There's special properties revolving around that midsegment. First of all, the midsegment is parallel to the bases. So now all of a sudden we have a third parallel line in the middle of this thing. So that's kind of neat. All right. And that'll tell us a lot about the angles of this thing. All right. The second thing is that the midsegment, we can find its length by doing the average of the bases. Okay. And so when we talk about the average of the bases, here's a little formula that they typically give you to find the midsegment. It's 1/2 base 1 plus base 2. You could also think of it as base 1 plus base 2 divided by 2. You're literally just finding the average. Remember, when you find the average, you add things up and divide by how many you have. So if I want the average of the two bases, I add the two bases together and divide by 2 because that's how many bases I have. So it's just the average of this thing. Okay. And so when you look at this again, if you connect the middle of these legs, so here's the midpoint and the midpoint of each of those legs, if you connect that with a segment, this is called a midsegment. And the thing that's special about this midsegment is that it's parallel to the two bases. So it's parallel to each of those guys. And it's the average length of those two bases. So if I add these guys together and divide by 2, it gives me the length of the midsegment. For example, if I look at these, it says find the value of x and the measure of angle 1. And so as I look at this thing, first of all, if I want to find the measure of angle x, since this is a midsegment, and I know that because it's showing me that these pieces are congruent and these pieces are congruent, so I know that these are the midpoints. So this is a midsegment, which means that middle piece has got to be the average of the two bases. And so when I look at the bases, these guys, I want to find the average of those. Well, that's just add them together, divide by 2. 15 plus 7 divided by 2. And 15 plus 7 is a 22, divided by 2 is an 11. So that's the value of x. That's the length of the midsegment. And the other thing that you should note here is when you think about the midpoint, think about the midpoint, the midway value between 7 and 15 is an 11. When you talk about the average, remember, we're still talking about the midpoint. And so to find the midsegment, we connect midpoints. The length of the midsegment is literally the midpoint value. All right. And so hopefully some of that is easy to remember. Okay. The other thing that we know about the midsegment is it's parallel to the other sides. And so once again, when you look at something like this guy, if all three of these are parallel, okay, we know that parallel lines go off at the same angle, which means if this guy right here, this measurement is 115 degrees, well, then this measurement right here must also be 115 degrees because they're parallel lines. They have to go off at the same angle. So the measure of angle 1, well, yeah, that's going to be 115 degrees, okay? If I look at the next one, same kind of thing. Here I have the midsegment drawn. And once again, the midsegment is the average of these things. So if I find the average, or maybe you want to look at it and just say, hey, what's halfway between 10 and 28? And if you can kind of think about that on a number line, that's the value of x as well, okay? An easy mathematical way to do it is just to say, hey, you know what? Halfway between these, just the average. So let me find the average of these guys. So I add them together. That is a terrible looking 3. Let me try again. I add them together and divide by 2. So let's see, that gives me a 19. Okay, so x is a 19. And then from here, I want to find the angle. Once again, I know that these are parallel, which means they go off at the same angle. So if this guy right here is 135 degrees, it means that this guy right here is also 135 degrees. Okay, and that's not the angle I was looking for. Okay, but remember the special relationship between these two angles, this guy and this guy, is that they're supplementary. They add up to 180 degrees. You could also just look at this guy and say, hey, this one has to add up to 180 degrees with the 135, which makes this a 45-degree angle. Okay, and now you could look at the parallel lines again and just say, hey, watch this. Ready? They have to go off at the same angle because they're parallel, so this angle has to be the same as this angle. Okay, so there's lots of ways to kind of approach this, but we have to think about that idea of parallel lines go off at the same angle. So which of these angles are going to be the same? Okay, so 45 degrees. And a lot of times angles come down to this. They come down to some angles that add up to 180 and some angles that are the same. Okay, so the mid segment makes that thing parallel so we can find certain angles that are the same. It's also the average in terms of the length.